Hello everyone and welcome to this new module, C Programming. We will learn about the practical applications learned in the previous module, that is programming practices and techniques. And for those of you who just want to learn C, you'll also snugly fit in as we'll start the first session by an overview of the general programming practices. And without further ado, let's jump right in and look at the session objectives. By the end of this session, participants will be in a position to distinguish or differentiate between a command, program, and software. You'll also be in a position to understand the beginning of the C programming language. You'll also be in a position to explain when and why the C programming language is used. You'll also be in a position to discuss the C program structure. You'll also be in a position to understand algorithms and how to implement them using flowcharts. And we will wind up the session by looking at the symbols used in flowcharts. Let's start by understanding the distinction between a software, program, and command. Now, I want to use a practical example. I believe when we look at things, we actually get to understand them much better. And to assist me, I'm going to use the Microsoft Office applications. I have Microsoft Word open and also Microsoft Excel. If we look at this, we are aware of the ribbon interface. I hope so. And the ribbon interface basically is made up of commands which are bundled together in groups, like we have the font group. These are the most commonly used commands that we use to format our work. Now, the commands basically execute a well-defined command, like let's say making text bold. And after that, we actually put all these commands into a single application, which you're calling the program. The program can be something like Microsoft Word or Microsoft Excel. And once we bundle these programs together, we call something we call a software suite. For example, we have the Microsoft Office suite, and we also have the Adobe Creative suite and so many other suites. And I hope now this helps you to understand what it is that is happening here. We have the commands like bold, italicize, and such. We had the programs like Microsoft Word, Microsoft Excel, PowerPoint, which I'm using. And once we bundle these all together, we come up now with a complete software. Now, having understood what a software is, let's look at the beginnings of the C programming language. And we go back all the way to the 1970s and 60s. So we start with BCPL, which was made by Martin Richards. This is in the late 60s. And BCPL is the acronym for Basic Combined Programming Language. And this was followed by the B programming language. And this was credited to a gentleman called Ken Thompson. And later on in 1972, Dennis Ritchie came up with the C programming language, which also derived from this. And if we look at this, you can see B actually is the first letter here. Of course, naturally, C had to be the second letter. Now, we credit this to Bell Laboratories, where this gentleman worked. Now, after having looked at a condensed history of C, where do we use the C programming language? Let's look at the application areas of C. Now, C was initially used for systems programming, and a system program forms a portion of the operating system of the computer or its support utilities. Operating systems, interpreters, editors, assembly programs are usually called system programs. The Unix operating system was developed by C. So some of those questions I get from my students, where do we actually use C? The Unix operating system is a very good example of an area where we use C. Now, we have various compilers available for almost all types of PC. Just a backdrop to the history. Now, once Dennis Ritchie made the C programming language, he actually put it out there for developers to see what they will do. And universities and other institutions actually came up with their own versions of the C compilers. But this was standardized later by the National Institute of Standards. And we have been having various standardized versions of the C programming language. Now, where exactly does C fit in the programming ladder? Now, C can be classified as a mid-level language because it offers you the capabilities of high-level languages like Java or something like C Sharp. You program in English like statements, but it also gives you like the power and flexibility of the assembly language, whereby you can create code that is very close to the machine language, meaning that once you write your programs in C, they execute very fast. C is also classified as a structured language, and it allows you to compartmentalize your code and data. Compartmentalization simply means, I'm quite sure where you're watching this, you're in a room or some enclosure. Now, those walls are basically blocking out everything else that is happening around you. And what usually happens is that C allows you to do something similar with your code and data. The compartmentalization refers to the ability to section off and hide all information and instructions necessary to perform a specific task from the rest of the program. In a given room, you are really not aware what is happening in the other rooms. So that is what is offered by C. Code can be compartmentalized in C by using functions or code blocks, which we'll be looking at later. And you can see here, we have an example of the do-while loop. If all this sounds strange to you, don't worry, you'll get the hang of it once we look at looping constructs or iteration constructs in the sixth session of this particular module. Let's move on. About the C programming language. The C programming language has 32 keywords, and I'm quite sure you're wondering what is this keyword business? Keyword simply means a word with a special meaning in a given programming language. In other terms, we call them reserved words. Now, these keywords combined with a formal syntax, they form the C programming language. And there are some rules which we follow when we are writing programs in C. All keywords in the C programming language are basically in lowercase, and C is case sensitive, meaning that do while in lowercase is quite different from do while in uppercase. Keywords cannot be used as the names of variables or functions or constants, and these are called identifiers. They are basically telling us the name of either a function, a variable, a constant, a structure, or any other type that we use in C. You can see an example on the lower right side. How do we write programs in C? Let's look at the C program structure. C programs are divided into units called functions, and irrespective of the number of functions in a program, the operating system always passes control to the main function when a C program is executed. The function name is always followed by parentheses or brackets, and the parentheses may or may not contain parameters. That is the data that your function requires to do something specific. Like, for example, if it's supposed to add two numbers, you're going to pass in the two numbers as parameters. Okay, let's look at a practical scenario, or let's look at a practical program. This is available via the URL shown on that caption, which has just appeared there. And we can use this site, or we can use Coding Ground, which is available from Tutorials Point. But I prefer this one since it allows you to work with input from the user, while the one from Coding Ground does not allow any inputs as per the time of this recording. Let's look at this very quickly. So we were saying that the main function, that is line 11, is where our program begins. And we are saying that your program can have so many other functions, but this is where the operating system passes control once your program starts executing. We have the delimiters, that is the opening and closing curly brackets or curly braces. And the function definition is followed by an open curly brace or the left brace. This curly brace usually signals the beginning of the function. And similarly, we have a closing curly brace or the right brace after the code in the function, indicating the end of the function. This is now what we are calling compartmentalization, meaning that The left brace or the left curly brace is where we are starting from, and we are going all the way to where we have the right brace or the right curly brace. We have the statement terminator. Now, a statement terminator is the semicolon that is in the C programming language, and all C statements are terminated using a semicolon. Works like your English, where you end a sentence in either a full stop, exclamation mark, or question mark. Okay. A carriage return, white space or a tab is not understood by the C compiler. We are talking about like you tapping on enter, the tab on your keyboard. Basically, those ones are ignored by the C compiler. And a statement which does not end in a semicolon is treated as an erroneous line of code in the C programming language. We also have comments, and comments are usually written to describe the task of a particular command, function, or the entire program. The C compiler ignores them, and in C, the multi-line comments, that is what you're seeing here, they start with a forward slash, then an asterisk, and then you can write your several lines of code, and after that, we then have the asterisk, then the forward slash. We also have the single line comment. Let me just show you here quite quickly. So this is what you're calling a multi-line comment, and it can span as many lines as you need to explain the purpose of a program, function, or line of code. And we have the single line comment, and this one we have 2 forward slashes. This one usually spans 1 line of code. We move on. We have the C library. Basically, all C compilers come with a standard set of library functions. These are usually inbuilt into the program. They actually help you to build your code much faster rather than having to do everything from scratch yourself. You don't need to reinvent the wheel. You can actually borrow some of the functionality which is already there in the C library. So all C compilers come with a standard library of functions, and a function written by a programmer can be placed in the library and used when required. Some compilers allow functions to be added in the standard library, and some compilers require a separate library to be created. So this is determined by the compiler that you're going to be using to compile your program. Now, the next question you might ask me, what is this thing you're calling a compiler? A compiler is a program that basically converts the code that you write into something that the machine can understand and execute. And hence, let us look at the process of compiling and running a program. Now, we have the hash include directive, okay, and we have your source file. These actually go into the compiler, and once you combine these two plus other library files which have been developed either by you or other programmers, you get the object file. We'll see this once we start learning the practicals. You could also have other user-generated object files, and these go into the linker, and once the linker puts everything together, I don't want to use the word link again, we actually get the executable file. The executable file is that program that your computer, be it a Windows machine, Linux machine, or any other machine that you're using, is able to understand and execute. Let's see how we solve problems by using the programming approach. The programming approach to solving problems. Now we have an algorithm, and an algorithm is simply a set of steps which are performed to solve a given problem. And the example below describes an algorithm. Now we have a lady here who's in class, and she wants to head over to the cafeteria after the class and maybe catch up on the weekend's activity with her friend. So let's see how she solves that particular problem. Once the class is over, she will leave the classroom. She can head toward the staircase, and after that she'll go to the basement, head for the cafeteria, and there she can order some drinks and enjoy with her friends as they catch up on the weekend's activities. These are the steps followed when a student wants to go to the cafeteria from the classroom. Actually, there was a problem, and the student has been able to solve this. And they do this quite intuitively without thinking about it. Even you, with time, you'll actually be solving computer problems without thinking about them, no matter how daunting at this stage that may seem. How do we solve a problem? In order to solve the problem, we always start by understanding the problem clearly. And this is actually quite a big issue of contention between developers and the users of the system, or a software firm and the customer, if the requirements were not clearly laid out and understood. But once everything has been clearly understood, then it's very possible to come up with a solution. Once you understand the problem, you need to gather the relevant information, process that information, and then you can arrive at a solution. Let us look at the ways that we can use to come up with simple solutions to simple problems. We have pseudocode. Now, pseudocode is not actual code, and pseudo comes from the Greek word pseudo, meaning false, and it is a method of algorithm writing which uses a standard set of words which makes it resemble actual computer code. But please note that it is not actual code. Let's look at this. The program I displayed earlier, that is the hello world, this would be a very simple pseudocode for that program. We want to display hello world on the computer screen or the console. We begin, then we have the statement display hello world, and then we end. Each pseudocode starts with a begin, and to show some value, the word display is used. The pseudocode finishes with an end word. We can also use a flowchart, which I mentioned earlier, and a flowchart is nothing but a graphical representation of an algorithm. Let's look at the flowchart to represent the same program we had earlier, that is the hello world. We have start, which is in a rounded rectangle. Then in a parallelogram, we have display hello world, and finally we stop. It's actually quite simple. Let's look at the symbols which are used in flowcharts so that it will become easier for us to diagram them out or to draw them out. We have the rounded rectangle, which basically denotes the start or end of the program. We have a rectangle. This denotes the computational steps. We have the parallelogram, which shows the input or output instructions. We have the diamond, and this is used when we want to make some decision in our program. We have the connectors when our program is quite large or we have several flow lines which we want to connect, then we can use the connectors. And below that, we have the flow lines. Let's look at an actual example. Here we have a flowchart that will show us the steps in writing a program to add two numbers. We have the terminal symbol, which is used to denote the beginning of the flowchart, and you can see it's labeled start. We have the parallelogram, which basically shows us the inputs which are required from the user. We require two numbers which we want to add. So we use the input-output symbol, and it is used to allow the user to input two numbers. We have the rectangle, which is the process symbol, and it is used here to add the two numbers. We can see here that we are adding A and B and assigning the result to C. Then we have another input-output symbol or a parallelogram, and it is used to display the sum of the two numbers. Once we do that, the program has served its purpose and we stop. We have the terminal symbol, which is used to end the flowchart. Let's look at another example where our program needs to make some decision. And we're going to do this using the if construct. Now, on the left side, we have the pseudocode, and on the right side, we have the flowchart. So you can always feel free to use whichever it is that you're most comfortable using. Begin, we input the number. Then we have R, which is given by the number modulus 2. Modulus simply means you do the division and then you discard the number and you pick the remainder. Let me illustrate practically. Let's look at a number like 5 divided by 2. So we have 5 here. Then you divide by 2. 2 goes 2 times into. So 2 times 2 is going to give us 4. then we do the subtraction and we get 1. Then we write that 2 remainder 1. Now this is what you're calling the modulus or the modulo in some other textbooks. What usually happens is that we are interested in this part here. Okay, this is now what you're doing there. R is equals to num mod 5. So this could be something like 5 modulus 2. Once we do 5 modulus 2, we assign this value of 1 to R. Then we check. If R is equals to 0, then we can display the number is even and we end the if selection construct and we finally end the program. Now let's do another example. We're going to divide 8 by 2. Same process. 8 divided by 2. This goes 4 times into 8. 4. Then you get 8. Subtract, the remainder is 0. R 0. Okay. And as usual, we are interested in the remainder, this part here. If this is now 8 modulus 2, the remainder will be 0. So if the remainder is 0, then we display that the number is even. Now let's see where we have two possible paths. Now here we have two possible paths. We prompt the user for the number, then we do the modulus, and once we do the division, we assign the remainder to R. We check if the remainder is 0 and we inform the user that that is an even number. Else, we tell the user that that is an odd number. Now, looking at the flowchart, we start same set of processes, parallelogram, input-output symbol, then process the rectangle. We do the calculation here and assign the remainder to R. We come here using the diamond symbol. This is the decision-making symbol, and we check. For example, if it is 8, then the remainder will be 0, and we display that the number is even, and the program stops. Or if it is not 0, then we tell the user that the number is odd, and the program stops. Now, this is where I was saying that we can actually use the connector symbol. These connectors here when we have multiple flow lines converging in one particular place. What about if you have multiple criteria? Like let's say this is supposed to happen and this for this decision to be made. Let's look at that scenario. Now here we have multiple criteria using the and, or, and we begin. Now, the purpose of this program is we want to find out if a customer can be classified as a most valuable supplier. The criteria is 1, they must have been doing business with us for at least 10 years or more, and the amount of business should be at least 500K upwards. So the program begins. We prompt the user for the number of years, and then we also prompt them for the amount, that is biz done. We check if the number of years with us is greater than or equal to 10 and the business done is greater than or equal to 500,000 or 500K, then we tell them that they can be classified as a most valuable supplier. Else, if we don't meet any of these two, then we tell them that a little more effort is required. We end the if and we also end the pseudo code. There's also another alternative solution to this particular program whereby you can put an if within an if. This is what we call a nested if. Let's see, same program requirements, but now we're using a nested if. We begin, we get the number of years from the user, and we also get the amount of business done with us. The first check is if years with us is greater than or equal to 10. Now, let's say if it was something like 11 and 700K. Of course, 11 is greater than or equal to 10. So we come inside here and make the second check. Then we check and find out if 700K is greater than 500K. Then we can display classified as an MVS. If it was 11 years and let's say 450K. So the inner if would not pass. We would tell the user or the supplier a little more effort is required. What about if it was something like 8 years and 700K? What would happen is that we would come here and compare the 7 with 10, and this would evaluate to false. Once this evaluates to false, then this entire block of code will not get what? Will not get executed, and we skip directly to the else, where we tell the user or supplier that a little more effort is required. We end the if statement, and we also end our program. We have a flowchart showing this in the subsequent slide. Let's look at it. This is the flowchart of the previous pseudocode, and I have some values, and we are going to look at this so that we can arrive at the respective decisions. Now we have supplier X, Y, Z, and N, the years that each of them has been trading with us, and the amount of money that we have transacted business with them. And we want to use this program to get the possible outcomes. We're going to start with supplier X, and we input the years with us. We input 5. Then we input the business. Business is 750K. Now we come here and check 5 greater than or equal to 10. No. Then we tell these guys a little more effort is required. So here we can just quickly fill in more effort. Okay. Then we go to the next one. We have Y. We have 15 and 490. We come here and compare this 15 with 10 here. Is 15 greater than or equal to 10? Yes. Then what exactly are we supposed to do? We check the amount. The amount is 490K. We compare 490 with 500K. Is 490 greater than 500K? No. We have the same output. We tell them a little more effort is required. Here we tell them more effort. Then the next one is Z. Years is 7 and the amount is 488K. We come here and compare 7 with 10. Is 7 greater than or equal to 10? No. We tell them a little more effort is required, and the program stops. The outcome for this is more effort. Then we look at the last supplier, N, and we have the years as 12 and the amount as 770K. We compare 12 with 10. Is 12 greater than or equal to 10? Yes. Then we come and compare the amount. The amount is 770K. We come here. Is 770K greater than 500K? Yes. We display that this is an MVS, and our program finally stops. We can classify this as MVS, and that is how our program would arrive at these possible outcomes. With that, we've come to the end of the session. Let's quickly recap what it is that we learned. In this session, we've seen the distinction between a program. We've seen the distinction between a command, program, and software. We looked at the brief history of C and its application areas. We saw the C program structure. We had a brief introduction to algorithms, flowcharts, and the symbols used in them, and pseudocodes. We also had an introduction to programming constructs like decision-making and iteration or repetition constructs. And that marks the end of that particular session. Let's look at what we'll be covering in session 2. In the second session, we'll be looking at variables and data types, and some of the objectives to be covered are: by the end of the session, you'll be in a position to discuss variables, to distinguish between a variable and a constant, look at the different data types and make use of them in C programs, and we will wind up that session by discussing the various arithmetic operators used in the C programming language. With that, we've come to the end of our first session in C programming, and I hope you look forward to the subsequent sessions, which will help you to better understand the C programming language and the C-like languages. Have a nice time and God bless. Bye.